And welcome back. Today we're going to take a look at graphing quadratic functions. Now, first of all, I've written that on the board already. A quadratic function is any function that is in the form of y is equal to ax squared plus bx plus c, where a is, actually cannot be equal to 0, right? This is another important thing for us. Now, a is actually known as the leading coefficient, right? It's the coefficient that's multiplied with x squared. For example, if I have a function like y is equal to x squared plus 2x plus 3, the leading coefficient here is actually 1, despite the fact that it's not written. And if it's written, then, for example, it could be 2, right? Now, a good piece of information that the leading coefficient, or a, gives us is the fact that if a is positive, then a graph opens upwards. It's going to be a smiley face, right? Upwards. And then it's actually showing you the minimum. Okay, shows you the minimum point of the graph, right? But if the graph, if the leading coefficient a is actually negative, our graph opens downwards. It's a sad face. And we actually have a maximum then, right? Now let's go ahead and take a look at a very simple example and actually the parent graph of a quadratic function. So example, graph f of x is equal to x squared, right? How do we go about graphing this? Now, before we learn anything about, I'm pretty sure you guys have already heard about all those fancy things, the vertex, the this, the that. I'm just going to teach you how to graph it using a table like we've learned in Algebra 1 in grade 8. So the first step over here is to actually make a table. So you make a table. You got the x right here and the y values right there. So there are 4 values for the x's that are actually known as our golden values because they always allow a quadratic function to shine and be, get that beautiful shape, the parabola. And those numbers are actually -2, -1, 0, 1, and 2. So in order to find the values of these, you know what to do. You just have to plug them back inside f of x. For example, I'm going to do one of them, f of -2, that's going to be -2 to the power of 2, which is 4. You get 4. And then 1 in there, you get 1. 0 in there, you get 0. 1 in there, 1. Again, 2 in over there, you get 4. Now, take a look at this. For the x's that are actually 1 and 2, positive 1 and 2 and -1 and 2, they have the same y values, right? What I mean is that the value for -1 and +1 is the same for their corresponding y values. Let's see why. So I'm going to graph these points. I'm going to plot them on the basically the plane. So you got y-axis right here and the x-axis. So space the numbers evenly. You got 1, 2, 3, 4, and then 1, 2, 3, 4, 1, 2, 3, 4. Now notice that I didn't draw any lines for the negative part of the y-axis. That's because I don't have any negative y values. So first point is 0 and 0, which is right here. Then I have -1 and 1, which is right here. I'm not going to draw those tiny lines. You guys know what I mean. And then I have -2 and 4. It's right here. So it's right around here, right? Let's just to be sure. And then you got 1 and 1 right here, and 2 and 4 once again right here. So the graph looks a bit like this. You got this part, and you got this part. Okay. Now, the cool thing about this graph is, as you can see, the right side is like a mirror of the left side. So it's actually symmetrical. That's why if the line that divides these two parts into two symmetrical parts is known as the axis of symmetry, which is actually 1 over here, right? Symmetry. Over here, actually the axis of symmetry is actually, sorry, not 1. It's actually the vertex, which is right here. So the vertex, which is right here. And guess what the vertex is? It's the number that, or the part of the graph that touches the bottom part that touches the x-axis right here, which is 0 and 0 right here, right? Now this shape right here is known as a parabola. And as you saw, graphing it was not that difficult. Now, how do you go about graphing it when you're talking about more complex problems, right? It's all the same thing. For example, if you have, y is equal to let's do another example. Let's say, for example, they give you something like y, example b, or f of x is equal to 1 over 2x squared. What does this mean? So first you draw a table again. You got the x and y right here. Once again, you can use the golden values, or you can just, well, let's go ahead and use all those values that I just told you, -2, -1, 0, 1, and 2. You plug them back in here. You know, -1 to the power of 2 is going to be 1, so 1 over 2. And then -2 to the power of 2 is 4. So what I'm doing is -1 over 2 times -2 to the power of 2. That's going to be 4 over 2, which is 2. And then you got 0. Now over here, you can copy those values for the x is equal to 1 and x is equal to 2 from here. So you can just write 1 over 2 and 2 because of the axis of symmetry. Now, the next point is to just graph and plot these points. So you got, let's write them evenly again. So let's say this is 1 over 2, this is 1, this is 1.5, and then this is 2. So -1, -2, 1, and 2. So first point is 0 and 0, which is still right here. -1 and 1 over 2, which is right here. -2 and 2, which is here. 1 and 1.5, and then 2 and 2. The next point is to connect them all. So you connect them all, and as you can see, your graph is a bit wider, right? Now I'm going to talk about the translations of graphs later, because today I just want you guys to get introduced with the basic information. And the third example that I'm actually going to do is the final form of a quadratic function. Now, so these were just some basic questions. What about when the quadratic function is in the first term that I told you about? Let's say, for example, you want to graph something like, for example, y is equal to x squared plus 2x plus 3, right? How do you go about with this one? Over here, first you have to identify the coefficients. The coefficient of x squared over here is 1. The coefficient of x is 2. And c is 3. Okay, pretty simple so far. The second part is to find the axis of symmetry. The axis of symmetry is basically the x coordinate of your, the x coordinate of your vertex. So in order to find the vertex, we have a formula. The formula is x is equal to -b over 2a. This is known as the vertex formula for the x coordinate, obviously. So first you plug in, step 2 is to plug in the values that you have in that formula to find the x coordinate of the vertex. Because as you know, the vertex has two coordinates, the x and y. Now, let's go ahead and find the x coordinate. So it's going to be -2, because b is 2, over 2, so it's -1. Now, in order to find the y coordinate of the vertex, all you have to do is plug this inside your function. So you're going to get -1 to the power of 2 plus 2 times -1 plus 3. That's going to be 1 minus 2 plus 3. So the answer right here is going to be +2. Okay, so that means that your vertex is actually located at -1 and 2, right? Now, sometimes we actually can go ahead a step further and find the x-intercepts, but I'm not going to do this over here. I'm just going to show you the third step, where you can use this to find essentially the values on your table, right? So you got x and y, you write the vertex, which is -1 and 2. Then base your table around your vertex. So one value before -1, -2, and one value after -1, which is 0. Let's say I put 0 inside my function, which is x squared plus 2x plus 3. If I put 0 in there, I'm obviously going to get 3. If I put -2 in there, I'm going to get 4 minus 4 plus 3, which is again 3. All right. Third and final step, actually right here. Okay. Y-axis and x-axis. This is -1, -2, 1, and 2, and then 1, 2, 3. So you got negative 2 and 3, which is right here. This is negative 2 and 3. Then negative 1 and 2, which is right here. And 0 and 3, which is right there. So the next step is just to go ahead and connect your lines, and you have your graph. There you go. And this is negative 1 and 2, and this is 0 and 3, which basically means that you 0 and 3 is essentially your y-intercept. That's it. Thank you for watching, and good luck.